We are going to be looking at another problem from section 5.1. This is problem number 30. And looking at this, it has the following instructions. At the end of an advertising campaign, weekly sales declined according to the equation y equals 10,000 times 3 raised to the negative 0.05x, where y is in dollars and where x is the number of weeks after the campaign ended. We want to determine the sales at the end of this time period, and getting my pointer set to go here, and ink color I'll use blue here. Now on this particular, what we're going to be doing is, I don't know why that's up again, but what we're going to be doing is determining that at the end of the sales campaign, what we're going to have is that I don't have the right color yet. I'm not supposed to use red for ADA reasons, so let's try this again. And looking at this here, and I can't find where here it is. All right. What we're going to have then is we're going to have at this particular time at the end of the ad campaign, that's when things get started, and so our x is going to be equal to 0. So if we're taking this and substituting 0 in here, we're going to have 10,000 times, and then we're going to have 3 raised to the negative 0.05 times 0. Okay? Well, what we have is if we have anything times 0 is 0, and anything raised to the 0 power is just going to be 1. And so what's going to happen is all of this stuff here is just going to be equal to 1 because I have 3 raised to the 0 power, and consequently our answer is simply going to be the $10,000. That finishes part A. For part B, it says determine the sales 8 weeks after the end of the campaign. So after the end of the campaign, 8 weeks after the sales, this is when our x is going to be equal to 8. And so we're going to take this model and we're going to put in an equation, and we're going to have y is equal to 10,000. And then we're going to have 3 raised to the negative 0.05, so I have to get this correct, 0.05 times 8. Okay, now if I can get my calculator going here, okay, what I need to do is I'll make it a bit bigger so we can see what we're doing. I'll turn it on, and putting this into the calculator, we're going to have then 10,000. And then we're going to have times, and we're going to have 3, and this is going to be raised to the, let's just do this in the calculator, so I'm going to put parentheses. I have negative, don't forget that, 0.05 times the 8. Now you could have done this computation at the top here, previous to using the calculator, but this should give us our answer then, and we have an answer of, this turns out to be, and again this is in dollars, so I'm going to have $6,443.94. Make sure my decimal is good here. The next question is one that's just a little more thought-provoking, and it asks the question, how do we know by inspecting the equation that the function is decreasing? This is an exponential function, and on this exponential function the base is 3. 3 is greater than 1, but our exponent here, we have a negative 0.05 times the x. Since this is a negative exponent, then we can know that this is going to be decreasing, because that's the same thing. This would be equivalent to saying I'm taking 1/3 raised to the positive 0.05x. So these two would be equivalent. Now I have, this is supposed to be a 3. Now I see that since I have a fractional base here less than 1, that it would be decreasing. So either way you look at it, a base greater than 1 to a negative exponent is going to be decreasing. or a base between 0 and 1 to a positive exponent is going to be decreasing. And so that's how we can tell. This completes this problem, number 30 from section 5.1.